Okay, first thing um, I'm talking about the registration for summer. We're not doing anything until this Wednesday. Right now, the maintenance, so they close the portfolio. We cannot get in it. Okay? And the second thing, you understand, you get the theory and also you get the hand-on training. Now, any student not doing any left volt, I'm talking about student in tech group, and also you're not doing any hardware on the DLAB. So when we return to the class, you have to do both. Okay? Try to get as much as you can in order to complete the program. And we are going by the priority. That means you start from the fall. Okay? Uh, let's see. Right now we get the spring 2021. So you get the fall 2020 from summer 2020. That means you cannot do any left vote. So when we return, you have to do both. And the other people, the other students, they start from uh, spring. Okay? That means before you get to the summer 2020. They already done some on the left vote. So the priority they have to do is the hardware on the DLAB. As much as you can finish it, then you can get the complete certification. Okay? This is a take little longer than normal. In the normal, you get the 900 hours. Take around 3.5 semester. However, the thing is for COVID-19, the class closed. So what can we do? You see that? We cannot do anything. So we have to prepare as much as good for your lecture. When we return, then we try to helping you to get through. Okay, the hand-on. I don't think that much take too much. Okay, for current semester right now, for the student already done electronic last semester, then I like you to be in the lecture, make sure you're able to understand. I like you to do in the quiz in order to helping you ready apply for the technician job. However, I don't care. Okay, you can do or you're not doing that. Doesn't matter to me. But normally you apply for the company, and a company will be send most of the time they send letter to me, to the school, to get a recommendation for each student. That's why I can look into the history to see how you're doing in the program, and in order to telling, you know, good or not good or whatever. Okay, and also we try to get you very basic understanding for the technician job in the company. Okay, So when you get a company, you're able to get through quickly. So you can take the quiz if you want it. If you don't have to. And also assignment for Taekwondo, we already telling you. You don't have to do it. Right now we on Taekwondo. Concentrate on the Taekwondo. You still confusing in the electronic later on for spring for the fall, okay, 2021, okay, then you can start learning again. This is a continuing education, okay? You allow anyone want to learn can be registered, okay? So do you get any question able to answer you? Just bring it up.
Can you be nice on the recommendation later?
Yeah, normally depend on the individual. Okay, it's hard to say. The thing is when you get a interview job, I also on Zoom with you try to telling you what they supposed to be asking you. You learn too many things in the program, but normally interview they just asking for basic understand. Okay. Yeah, cool me, that's very good. Very hard study.
Thank you.
Yeah. The thing is whoever in the program, okay, I already know some. The thing is I saw the online all the time. Okay. You want to get the real technician after the program. Right now everything will be more difficulty, but they will be okay for the end of the year or next year will be uh, good, but you must be ready for that. Otherwise, too late, you know. Yeah, anything else, just let me know.
Thank you, Mr. Pham.
Yeah, no problem. I do the best for the guy.
Yes.
And also, you see, sometimes something you learn one time you can still not understand. Have to be few times. Okay? If you want to do it, you have to study. Don't try to read too many different textbooks. Who care? Only thing I want is you can follow the lecture. Then you're able to do it. Reading over and over and over. Now, on the lab right now, what I want you to do, okay? Try to do the up-to-date lab. That means right now we on lab number 9. Okay, don't care about whatever in the past. After you can do a number 9 or number 10, when you're going back, you can see that it's not hard to do it. If you still keep working on 1, 2, 3, 4, 5, 6 or whatever, you get lost. Okay? So now we start with the lab number 9. I want to go through that. Okay? And also, anyone get lost, please let me know. I can working with you. Okay? This is a memory test. If you're looking on the schematic here, you can see how many IC we'll be using for this circuit.
N.
Okay, you count by yield number. 1, 2, 3, 4, 5, 6, 8, 9, and 10. That means the total of the 10 IC in the circuit. Build the circuit is not hard to build. Understand the circuit, that is the important thing. So the first thing is when you look into the circuitry, what I recommend, you have to know for each IC how they are working. I given you example. U1 here, you already know. You get a serial data coming in here, they converting into the parallel data here. That's a very simple thing. Okay? And also, in order for the serial data coming from pin A and B, you need a one clock for 8 bit. So basically, you need 8 clock. They will be sent 8 bit serial to 8 bit parallel in here. And that one you don't have to do. We already get a function. Okay? That function, you just using that function. They do the rest. That means I say, you call that function, you want data will be 0x or 0, 1. That means you can get 0x, 0, 1 at the output here. Okay? Only thing you need to know if they asking you, what did I see? Then you say that converting 8-bit serial to 8-bit parallel. Normally, they not go into the detail. The thing is, the people interview, they already forgot everything. They don't want to asking something and they cannot know is it right or wrong. Second thing, U3. U3 is a buffer controlled by pin 1 and 19. Okay? If pin 119 equals 0, then whatever at the input D will be go into the output queue, nothing else. If the pin 119 at the logic 1 look like this IC will be not there, they will be high impedance, so they cannot loading any data, any current. Okay?
Sorry, when that happened, Mr. Pham?
When that happen, depending on the way they're using. For example, for this one, if they want input at the input here, D1 to D8, go to the output, then pin 119 must be 0. And now you go in here, they control by the decoder.
Okay, okay.
Okay? So that means you have to know pin 2 and pin 3 must be 0 is 0, so pin 4 can be 0. Okay? So that's a U3, just a buffer.
Okay, U3, 0, okay, allow the output, but when it is 1, it is high impedance.
Right. If 1,
U3.
that means you cannot do anything with U3.
Okay,
If they want.
okay, okay. Thank you.
Look like they're not there. Okay? And now, U7 the same with U4, U3, right? 541. 541. They the same.
U2 also.
That means input here can go to the output here if pin 119 is 0. If pin 119 is not 0, they 1. Look like you don't have a DIT IC in the circuitry. They isolate it. Exactly the same thing. Also, the same happened to U2, 541. However, U2 119, they tie to the route. That's only telling you, no matter what, when you get the input here, automatically they go to the output here. Okay? Any question up to this point?
Just
Okay.
something minor, Mr. Pham. Maybe it's no big deal. It's probably no big deal. On U10, did you put U10A, U10C, U10D? What happened to B, or you didn't need a B?
Depending on what we get in here. Okay? U10 A and U10 D. Okay? And you don't have a U10 B, right?
Right,
That's
but you got a U10C.
okay. What U10 here?
That's C, U10C.
Let's see. Okay. CB,
No, you don't have a U10B.
U10D right here, right?
No, that's D. D is in David.
D, David.
Yeah, that's U10, D as in David.
Right. Which one we missing?
Well, no, I don't know if you're missing. Maybe you did it like that on purpose. I don't know.
Oh, that's okay. That doesn't matter.
Okay, that's what I'm saying. Yeah, okay, it doesn't matter.
Doesn't hurt anything. Okay. Now, U5. 72, 173. What is it?
That's where you do the latch.
Latch, correct. That's the D latch. You know the D latch, how they working. Okay, now, first thing. You get the input at the D0 to D7. Okay, and you get the output Q0 to Q7. So, if you apply the input at D0 to D7, if LE last enable at the logic 1, then the data at the D0 to D7, they will be loading inside IC, inside here. They stay in here, but they're not coming out. If output enable, not 0. Okay? However, in this case, they connect output enable to be route 0 on the time. That's only telling you, if you get the input at D0 to D7 and pin LE at the logic 1, automatically they will be go into output here. Okay? Now, what happened if LE at the logic 0?
It stays inside the chip.
That means whatever data here changing, they cannot go inside.
Right.
Okay? That means only input will be go into here if LE equal 1. That
Hey, Mr. Pham, can I say something real quick?
yeah,
Okay, so basically, for U5, it's like somebody's at the front door. And when LE is 1, the door opens and they can go inside. But if LE is not 1, you can't open the door and go inside.
exactly.
And then on the pin 1, since it's grounded, once if LE is 1 and pin 1 is 0, then the door gets open, it goes inside, and then it's allowed to go out.
Right. That means whatever inside will be automatically coming out.
Right, gotcha. Okay, gotcha.
Next one, you see. 374. What is it? You understand me? I given you the IC already. Okay, we already get the more IC data or more IC. Okay, you have to look into that in order to know how they working. Now I can tell you. You see just the D flip-flop, but they control by the clock. Okay, you see the clock here. Okay, that means when you get the input at the pin 3 to 18, if you want to go loading that to inside the IC, you need to apply positive clock at the pin 30, 0 to 1 transition. Then they will be loading here, but they're not coming out until pin number 1, output control is 0. Then input inside music will be go output.
So, Mr. Pham, you're saying that pin 1, the OC, is sort of like pin 1 on U5. It's kind of like an output enable.
Right. Either
Okay.
I can say output enable or output control depending on different manufacturer.
But it's the same thing.
Same thing.
Okay.
That means pin 1 0, then whatever inside UC, they will be go into the output of the UC.
I know we have no control over it, but it would be a little easier if there was an industry standard for what to call it.
Yeah, I know, Adam, they got a bunch of different names for all this stuff.
Okay, so U7 we already done. Okay, U9 that's the NAND, U10 inverter, U4 decoder, we already get to it. Only the last one, memory. U number 8. If you're looking on the memory, U number 8, how many address they get? How many wire address?
11.
Right. A0 to A10 mean 11. So we want to know how many locations inside this memory. You know the formula, right?
2048.
2048. That's what you're using the formula 2 to the power 11. That's correct. You know it. So basically inside, they get total will be 2048 address, 2048 location, or 2048 word. Okay? How many bits per word? How many bits per word per location?
8.
8 right here. You see that? The data right here. And you see the data, they will be bi-directional. They can go inside the memory. They can be outside the memory. When you read data coming out of memory, when you writing, data go inside the memory. That's a bi-directional. Okay? On this lab, I routed A8, A9, A10. So basically you can get only A0 to A7. So for this lab, how many locations do we need to test? How many locations do we need to test for this lab?
8.
8 only. 8 location is not right. 8 wire. But that is not 8 location. How many locations?
256.
Perfect. You using formula. 2 power of 8. You get to 56 locations need to be tested. We can test everything, but that take a very, very long time. Okay? So we try to make sure you know how to do it. If you look,
Mr.
yeah,
Could you repeat about the words? You said we identify we have 2048 location for this memory. And then I lost the part about the words.
each word will be 8-bit.
Okay,
The thing is right
Okay.
here.
okay, because we have eight
Right.
wire input output
Right.
wires. Okay,
Okay? However, we test only 256 words, 256 location. The thing is we already route A8, A9, A10. We don't care. Okay, and now if you look into the memory, you get the pin 21, drive 0. That tells you pin 21 0, you want data to write to the memory. Okay? And if the pin 21 at the logic 1, you want the data read. That means data coming out from the memory. Okay?
Hey,
And
Mr.
also you can see pin 20, okay, active low. When you write, that means you get a 0 right here. So go inverter, they will be 1. That means they only allow data to write in here. Only thing is when you want to read, then pin 20 will be 0. They allow signal coming out. Okay? Last one, enable.
The fam.
Yeah,
What is pin 20? Because when we went over the memory chip, we only had 2 chip, two pin. That was read and write, and then enable. So this one have 3. So what is G?
okay. What I'm telling you, G mean what? When you write the data, they not enable output. That means G must be at the logic 1. So data only coming in, not coming out. And also you understand different memory. Okay? They get a different way to control. If you want to write data to the memory, pin 20 must be 1. 21 must be 0. So that's why I design when you write 0 here, automatically they go inverter to make sure pin G must be 1.
So pin 20 and pin 21 must be opposite
Right.
all the time.
They must be opposite all the time. The thing is they go to the inverter.
And is pin 20 sort of another output enabled to allow you to read?
Right. Allow data from coming out.
Thank you.
That means when you want to read, that this pin must be 1, right? 1 when they go PD 1 here, now you pin 21 at the logic 1. And also pin 1 here go to the inverter pin 20 have to be 0. So the data will be able to coming out.
And would you, in a real world situation, would you see that configuration where you have them connected, but pin 20 runs through an inverter?
Yeah.
Or is that just for the ease of us to understand in class?
Right. No. That is normally design. I'm an engineer. I design the circuitry. Okay. So instead you have to make 2 different pin. Then you have to apply pin 20. However, if I'm doing this way, guarantee when you want to write, then pin 20 must be 1.
What do you call pin 20? What's the name for that?
That are output inside that allow input coming in or output coming out from inside of the memory. If you want the input coming into the memory, pin 20 must be 1. That's the way they control inside that memory. If you want to reading the data out of the memory, pin 20 have to be 0.
Hey,
Okay.
Mr. Pham, can you kind of write that down somewhere so we all can look at it and, you know, put write on one side, read on the other side, and then put down what 20, 21, and 18 should be,
Okay, let's see.
so we can actually see it?
Okay, so now, if you want to write to the memory, right?
Right.
Write data to memory. Okay, 14, pin U8, pin, let's see, what the pin for address? Pin number 3 to pin number 18. That will be address. Be ready. Okay, and U8, write pin number 21, right? 21. Right. Have to be 0. Okay. And also that will be telling you U8, pin number 20. Have to be 1. But you cannot do anything U8, pin 20. The thing is you cannot write into logic 1 into that. They take care when you write pin 21 to be 0 and they go to the inverter, they have to be 1. And then you also need U8. Let's see, data will be pin 2, right? 19. Data have to be ready. Okay, so that means you already get the address ready here. Okay, and ready right in here, address here. And you already get pin 21 logic 0. automatically they tell you pin 20 will be logic 1. Okay, and then you have to also apply the input data right here. Okay, so if you already run up there, then now only thing you have to do, enable U1 pin number, U8 pin number 18. You need to apply U8. Enable equal 1. U8 enable equal 0. Then U8 18 enable equal 1. That means you want the negative positive. 1, 0, 1. So now data will be go into the address. You already set it up.
Mr. Pham, didn't you, should that be 20 where you got U8-2 to 19 data be read? Go back to the schematic.
To be ready. That means
Okay, so U8, because you don't, what is U8 20? You got, no, 20.
you see right here.
Yeah, okay, that's 20. But if on your iPad or whatever, did you write number 2 or something else?
You add 20 right here.
Okay, well, what's that? What is that? The third line down. The third line down.
1, 2, 3 here, right?
No, one more line.
Here.
Yeah, what is that line? Is that U8?
That's the data. That means right here. Right here. 9 to 17.
Okay, but what I'm saying is that U8-pin 2 to 19?
70. Sorry. Right?
So that's U8-pin 2 to 17.
Right here.
Shouldn't it be pin 9 to 17?
17 right here. 9, 17. Sorry. Shoot, man.
Thank you.
Sorry. 9, not 2.
Okay. Thanks, Adam, because I was getting confused on.
No, I caught that too.
So if you want to write any data to the memory, you have to follow exactly that step by step. First thing you need to apply address. What location you want to write data into it. Then you can set the write pin 21 to be 0. And now you can apply the data pin 9 to 17. And after everything ready, you just apply negative positive to the enable. Now I try to explain to you why they need to apply negative positive. Why you want that to be 1, 0. Okay, now what happened if pin enable at the logic 1? What happened to the memory?
Are you talking about pin 18 at logic 1?
Yeah, pin 18 enable at the logic 1. what happened to the memory you ate?
Basically off, isn't it?
You can say they be off, but what that means?
Nothing happens.
No
It-
change.
It,
That,
loads and it won't transfer.
that means you cannot write data into the memory. And also you cannot read data from memory. Look like you ate nothing. If they add a logic one, add pin number 80. Okay,
Yes.
And so is a 0 will allow you to write?
zero allow you to write, allow you to read.
Okay.
Okay, active low. Now, why we have to do that way? If you want to write data to the memory, you have to get the address. You have to get the data. Okay, so when ready for address, when ready for the data, you put it low. So the data will be go into that address. However, after the first location, you want to write to another location. So when you want to changing address or changing the data, you don't want to go inside. So that's why you have to bring up to 1 again. Now you can set up address, you can set up the data. After it's ready, just put it low. So guarantee they go to that location. Otherwise, you can messing up. The thing is, if the pin enable low on the time, so you can address or you can the data, they keep going inside. You cannot control it. That's how do we write it
Hey,
data
Mr.
to the memory.
Hey, Mr. Pham,
Yeah,
you know what? Like, I just kind of wonder because every now and then I get confused on this. You know, like on 18, 20, and 21, they got the bar over the W, over the G, and over the E. So that means active low, right?
exactly.
But how come they don't put a bubble on that wire?
Well, depend on manufacturer.
Because everything has to have 17 different symbols.
And on the manufacturer. If you're looking on a different manufacturer, then maybe you see the bubble.
Okay, for instance, I'll give you an example. If you look at U5 pin 1, they got the bar over the OE, and then they got a bubble next to it.
Yeah, but I said depending on the manufacturer, I cannot do anything.
Oh, okay.
Okay.
So even though it doesn't have a bubble, but it's got the bar over it, it's still active low.
Exactly.
Okay, thank you.
We need to start a letter writing campaign to the manufacturers.
Okay. Any
Okay.
method for writing data to the memory. So basically, later on you can see all of the thing happen for writing to the memory. We put the one function, write data to memory, and what data you want to write. That means everything will be doing everything for you. You don't have to go one by one. No way. It's hard to do. So if you say write data to the memory 0855, so they will be applied 0855. And also they can telling you what location address you want. Okay, that coming later. Now, how about reading data from memory? Write data. Now we're talking about read data. From memory. Number one, we need the apply address. Number two, okay, you can set drive as the logic one. Number three, enable equal 0. Number four, get data out. That's more simple.
What happened to the G?
First thing,
Mr. Pham, what happened to the letter G?
which one is G?
I forget what pen it is.
Opposite of W.
Okay, it's
W here, right? Or what?
you had a letter on the chip that was G. Go up to where the
Oh, no, the G, you cannot do anything. You're talking about G right here.
Yeah, once you write to W, it takes care of G.
Exactly. You cannot apply anything.
okay, all right.
They go to the inverter. So that's what you want to reading data. You can see what the difference. First thing you have to tell which location, which address you want to read data. Then you have to set the different yield equal logic 1 for reading. And now enable, you can set to be 0. You don't have to set to the negative post. Why? The thing is when you get the address already and different yield equal 1, automatic data will be from that location coming out. That means you cannot write inside into the memory so they cannot mess them up inside. Depending on what location, automatically data coming out. Then you can get that data. Okay, so you can see everything now. In here, you get that number 1, okay? 1, 2, 3, 4, 5, okay? 6, okay? Then from 7, they want to loading of data into the location 0 to 42. After you loading data in that location, and later on you have to reading out, verify whatever you put it in, they coming out will be the same. Okay? And that will be using later on when you try to test DLAB converter. Okay? Then the next will be test the even address for data 55 and also odd address for data AA. And this is 10 and 11 will be reverted. You understand inside the memory, each location must be tapped for 0, 1, 0, 1, 0, 1, 0, 1, and 1, 0, 1, 0, 1, 0. Okay, and also they can get the even address, odd address. For example, for even, this is a 256 location. So even will be 0, 2, 4, 6, so on, up to 256. You get a total 128 locations. Then odd, that means you start from 1, 3, 5, 7, and so on, up to 255. So you can also you can get 128 locations. That means if you're testing for odd and even, okay, then you get total will be 256 tests. And another round for odd and even with the different inverting data, another 256. You get total will be 512 tests for even and odd. And you're adding 42 tests for the data you wrote it in. So that will be total around 600 tests. And we cannot run for all of them. Take too long. Okay? So
And write them one at a time?
yeah, when you try upload your program, then we will be run the test number 1 to the test for the AC data. That means up to the 42 blood 6. That means 48 tests. Okay? We don't care on even or odd. But normally in the company, then they have to run everything. But in the class, we don't have enough time. Okay? However, when you're working on your lab in the class, then you have to run. Okay, anything else?
I had a question about the writing the address.
Okay.
Writing the address versus writing the data, you just do the same. Well, you write the address first.
Okay,
Write the data.
okay, I tell you. In the function I gave it to you, function prototype. Yep, okay. I go write address to memory. Okay, integer add. Then that means when you call this function, you have to know which address you want to write. Then
Like 0xAA or 0x,
whatever.
yeah.
Okay. Then I get a function write data to memory, integer data. That means what data you want to write. Okay. For example, I say write address to a memory on 0. That means I will be write to location 0. And I call this function 0x55. That means I write to data 55 to that location 0. Okay. Then after that, I apply address, I apply data, and I call the function write to memory. Write to memory. That means they will be doing everything here for you. Okay. So that's why you call write to memory. Okay. When you're reading the memory, doing the same, you have to write address to the memory, which address you want to read. Then you can say read memory. If this data will be coming up. Okay. And when you want to test for memory ADC data here, I given you a 43 in the array. That means 43 data. Okay. So you write those data into a location 0 to 42. Then later on you read them back. Okay. So I already gave it to you most of things here. First thing I say test number 1. Test U1, U2, U3, U4. Data 55. Okay. Then you can call the serial. That means on the first one, the same thing, like normal. I writing data 55 here. Okay. When they go to the output U3, I need to enable. And then I wrap it back to U2 to verify correct data. That will be a one test for 55, one test for AA. So after the test number 1 and 2, later on, guarantee U1, U3, U2, okay, will be no problem. Okay? If they fail that 1 or that 2, either U1 a problem, or U3 a problem, or U2 a problem. Also, U3 119 go to U4, then U4 may be also a problem. That's what you think. You see, I say PCOP, public cause of failure. If the test fail, which I see could be got a problem.
1, 2, 3, or 4.
Okay, U1, U2, U3, U4. And now, second test, I just change that to be A and A. Okay, so now it failed. What do you think the peacock? That's what I try to say. Can you understand or not? If the second test, U1, U2, U3, U4, the second test, data change to AA. If they fail, what caused the problem?
Would it just be U1? Because U3, or no, maybe, no, but you've already tested U4, U3, and U2. So would it not just be U1?
No, it's not correct. I can tell you, you test 0, 5, 5, 5. That means you get a 0, get a 1, right?
Yes.
So I already telling you.
Oh, no, it would still be the same. U1, U2, U3.
Perfect.
Thank you. Because U4 we only has one function here, and we've already tested that.
Perfect. That is you really understand. For X, the binary here, okay, X line must be test for 1 and 0.
Because we're testing the outputs of U1, U2, and U3 for zeros and ones on each output pin.
Right.
Okay.
U3, pin 1 and 19, they already working. So it's not caught by U4 on the second test. You see that? Okay, normally this is the lab design in the program, in a real, okay, in the real circuitry inside the company. They're not doing this way. They don't care on that. They take that out. You see that? The thing like that will be adding more IC into the circuitry. The reason they only think make sure they can write data to the memory, address to the memory. Okay, so they don't need the U3, for example. Okay, now, and they say that number, let's say 3. That U6, U7, U4, U9, U10. U6, U7. U6 right here. U7 right here. Okay, and also they controlled by U4. Okay, now I'm telling you how this test will be. So the first thing I say, I writing 5 here. 5 here can go here. Also, they will be go to input of U6. Okay. When I apply the clock, I output enable here. Data will be coming out here. That means the data to the memory. However, I want to make sure the data right here is okay. So that's why I go back to U7. Okay. Then I make sure pin number 1 and 19 will be 0. So data from U7 going back here and they go into U2. So you can verify. So now, same thing. U6 have to be tested for 5 and AA. Okay. So data will be go this way. Go this one. Go into here. Go to A6. Drop it into U7 and go back here. So after you pass data second to test, they're telling you one thing. U6 and U7 will be working good later on. You don't have to do anything with U6 and U7. Okay? So finally, you test for the memory. Okay? You apply a thread here. You apply the data, go this way, go to here, and go to the memory. That's for writing. When you read it, okay, you must apply a thread here. Set it to reading, data coming out, and now they will be coming out same here. However, they not go this way. They have to go to U7, and you can verify it. Okay, and also I already given to you the sample here. Okay,
Mr. Pham, just real quick on that last example that you were just talking about, you would still have the same logic at the output of U6, but you just don't test it there, correct?
you're talking about U6.
When you say when you're testing the memory,
You must be apply the data.
you're not testing from U6. You want the data to run through U7 so that you can test it
No.
at port C through U2. But you would still have the same logic at U6 at that point because those are connected, no?
I'm telling you. You get test number 3, number 4. Okay. Number 1, number 2, you testing for this guy. This guy. Okay. And this one. 1 and 2. Now, test number 3. They will be sending data here. Right? And they go out of the U6. Okay. You see that?
Yes.
Then now they're not talking about memory. They drop it back to U7.
Right.
Then you enable U7 and you can verify through the U2. Okay. So if that test part guarantee U6 and U7, they pass for input data 5 and AA. That means U6, U7 will be no problem later on.
Right. I guess my question is when you're reading memory.
Okay, you're reading memory. So U6 and U7, only one will be enabled, not both.
Right. Okay. Okay. I see now. Okay. Thank you.
The data coming out here go into the bus right here.
I just saw that those are physically connected to the output pins of U6. So technically at that point, you would have the same logic,
Cannot.
but U6 is not enabled.
Right.
Yeah, when you're reading, stay there, Mr. Pham, when you're reading and that data coming back from the memory, it can't go into U6 because that side of U6 is the output side.
Yeah, also
And the-
outside, then they cannot coming in, right?
you're right. They
But
can't.
but you must be isolated. That will be controlled by U4 pin 5
Right.
decoder. That decoder allow U7, then they have to be disabled. U6.
Mhm.
Okay, thank you.
Okay, that is the way designed. If they enable U6, U7 must be disabled. The thing is they share the same wire.
Mhm.
Right. Okay, that was what I was confused about. Thank you.
Mhm.
And just one thing on that. So you're saying like, okay, the information goes to U6, and then once it goes to U6, then it can't go back. So it can only go through U7.
They can go U7 or U8.
Yeah, or U8,
Right.
but it can't go back through U6.
No.
No way.
Output cannot come.
U6 is not bi-directional.
Right, exactly. Okay, yeah, that's it, Adam. Good.
Did
That's good.
I use a good term there?
Yeah, that's good.
Okay. So now, if you're looking into my program here, I given you a lot of things to helping you. You can test number 1 and 2. What I want here, 3 what I want, 4, 5. Okay. And now write data here. Test number 6 here, and okay, we don't care about even. Okay, we care about test memory ADC data. I already given you all of the function definition. Okay, you only go up to this point, then you can upload. So make sure they verify it working. Then you can add in later on. Okay, that's not a big deal. But the function here I already given to you. Okay, I already given to you here. You can copy paste into your program. Okay, but what I want you to make sure you understand on each line of the program what happened, what going to do. Okay, that will be that's what I want. Okay, so any question? I said go ahead and do number 8 and number 9. Okay, as soon as you can. The thing is we still continuing on the digital in the summer. Summer only about 2 months. Okay, we can finish everything on the program for the DLAB. Okay, when we get back into the class, then we will try to verify your hardware working. Okay, and I will try to get the test system so you can able to borrow it. Okay, for certain time, or you have to run inside the class, but I don't want to be inside the class. Only thing when you need to verify for the instructor, then you have to do run one time. Okay, any question up to this point?
We'll scream, Mr. Pham, if something go wrong, we'll scream.
And I'm going to look up the technician hotline for Texas Instruments, and we're going to talk to those people about consolidating their symbols.
Yeah, the thing, Adam look like he know more now.
He's gonna be an engineer.
Yeah, I have a good teacher. I have a really good teacher.
That no double. I can see. He keep going, he can be engineer. You can understand what I'm trying to teach you. And no big deal when you go to the college. So now, San Diego City College or university, more they want to do a more theory, okay? Not more practical. The thing is right now, I still working with a few technician in the past right now, here on the FD, FU, or UCFD, and they still asking me, okay? They still let me know what course they take it and what recommendation. Sometimes they don't understand, they can ask me. If I know, I can help. I want your guy to be engineer also. But right now, currently, I want to be a real technician. Okay?
You gotta make you proud, Mr. Pham.
And in this situation, we don't want it. Okay? But what can I do? They told me, in the city, look like they will be open on the fall. Okay? But we have to wait until for sure. I know that is the truth. But seems to me they will. Okay? Otherwise, I close the class. Teaching and the people cannot doing the lab. That is not cannot get through the program. But I believe, we will be open very soon. Okay, any question? Anything else?
One more question.
Yeah.
So when you're writing to memory, you select the address, right? First, you have to send the address.
What address? Right?
Right. So
Yeah.
then,
Depending on the requirement.
right. No, but I'm just trying to understand the memory chip 6116.
Huh?
So you write the address to it, and it has to store that until you write the data and then enable it to write the data, right?
To that address.
Yeah. I'm just trying to understand. So how it can store the address for as long as it needs to, or does it only last so long?
They will be keep the data inside, right? And that location.
Until you change the data at that address.
Yeah, until you can different address or different data.
And then to read the memory, you again have to write to the address so that you know which data that you're actually reading.
Right. The thing is, whatever you wrote it in. You wrote it in data 55 at the location 0. When you're reading at the location 0, data must be 55.
It's like using a phone number. You use a specific number and then you have your conversation after you've already dialed the correct number.
I think so.
I don't know if that was a good analogy, but
Yeah, that's pretty good. Yeah, because then you know exactly the other person that's on the other side.
right.
Okay,
Thank you.
assuming that person pick up the phone, not their kids or.
Unless it's Sam playing a trick on you.
No, I don't play any tricks.
Okay?
Okay. All right, thank you.
Yeah,
Okay.
no problem. Until tomorrow, we can keep going to guarantee you go ahead and coding for the DLAB09 for me.
Okay.
So we can get at least people can upload, next time we can verify.
Mhm.
Okay. And also make sure you understand You don't care about electronic. Quiz, no more quiz. Okay, that means 22nd quiz already.
Mhm.
And also we get a final on June
May.
2nd. Okay, you want to take it, okay. You don't want it, no big deal to me. Only thing I recommend you better try to see can you do without any open note and the open book. You can get 70% more higher. Okay, let's just try to make sure refresh your memory, and that will be ready if you get an interview. Okay, we want to help you to get a job, so that's why I do whatever we need, but it's not try to forcing the people keep going over and over in order to get the certificate. Who can?
Hey, Mr. Pham, what classroom was that you in?
Yeah, the same question I was going to ask.
There's a fake one. Hey, Mr. Pham, I got a question for you. Can you go back to the spreadsheet on the software development page?
You mean on the?
Just, yeah, on the DLAB09.
Oh man, that's I have to share again.
Yeah, sorry.
Okay, which one?
Okay, if you go to the page, the tab where it says software development. So keep going down. Keep going, keep going.
It's on the very bottom of the tab, Mr. Pham. It's the bottom tab. It's test program and help and
This
software
page.
development.
This page.
Is that one?
No, next one.
Oh, you're talking about.
Yes, yes, there you go. You're getting there.
Go back up.
I already did it for you.
Oh, go back up one page.
Right
Yeah.
there, right there.
Hang on. Yeah.
Yeah, right there.
Down, right to the right. It's a PB on the right. If you go toward right.
Okay, which one is it?
Scroll down. Yeah, scroll down a little bit.
And then go to the right. Go to the right.
Go to the right. Here.
Yeah. Okay. Okay, right there, right there. No, no.
Don't ask me that.
Oh, don't ask. No, I'm asking you on the top. It say PB, and then you got 876544321. And I
Right, those are pin connection.
That's outside. Pin connect.
But then pin 1 from the diagram of port B is ground. So I just wonder how come that one's got 0101 going down.
PB pin 1.
Yeah.
PB when pin 1, that's connect to U4A
Right.
A.
B and B, yeah. Okay, my mistake. Yeah.
Okay, that is connected to U4AA. Yes.
Yes. Okay,
Okay.
yeah. I misread. All right.
Okay.
Thank you.
Okay.
All right. Thank you.
Okay. Everything looks good.
Tomorrow we're talking about that thing more. Okay.
Okay. Very good.
Thank you.
Thank you so much, Mr. Pham.
Thank you.
Yeah, we're talking to you guys tomorrow.